Hello students, how are you? I hope you must be enjoying my lectures. So let us today enjoy another topic on physics, that is gravitation. Now what is gravitation? Every body in this universe attracts every other body with a certain force known as the gravitational force or simply the gravitation. A formula for this force was given by Newton, and the law given by him is known as Newton's law of gravitation. This law states that every body in this universe attracts every other body with a force which is directly proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between their centers. So therefore, if we have two bodies of masses capital M and small m placed with their centers are apart, then the gravitational force, which is always attractive force between them, is number one, directly proportional to the product of the masses of the two bodies, that is F proportional to m into m, and F is inversely proportional to the square of the distance between the centers of the two bodies. Therefore, more the product of the masses of the two bodies, more is the force of attraction between them, and lesser is the distance between their centers, more is the gravitational force between them, and vice versa. Combining these two factors, we get F proportional to capital M into small m over r square, or you can say that F equal to capital G into capital M into small m over r square, where capital G is the constant of proportionality and is known as the universal gravitational constant. Universal gravitational constant. The word universal is added to this constant because its value is the same at all places in this universe. Now, definition of capital G. If capital M equal to small m, each equal to 1, it can be 1 kilogram or it can be 1 gram. And r equal to 1, it can be 1 meter or it can be 1 centimeter. Then from equation 1, we get F equal to capital G into capital M is 1 into small m is 1 over r square means 1 square, and that is equal to capital G. Therefore, universal gravitational constant comes out to be equal to the gravitational force between the two bodies, each of unit mass and separated with distance, unit distance. So how can we define universal gravitational constant? Universal gravitational constant may be defined as the gravitational force between two bodies, each of unit mass, placed with their centers unit distance apart. Now we come to units of capital G. From equation 1, we have capital G equal to F into r square over capital M into small m. Therefore, units of capital G will be equal to units of F into units of r square, that is Newton meter square over kilogram into kilogram, and that becomes kilogram square equal to Newton meter square per kilogram square in SI. And in the CGS system, these units are dyne centimeter square per gram square And the value of capital G at all places in the universe is 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square. It is because of this small value of capital G that the force between two bodies of common sizes is negligible and they do not appear to move towards each other. Now, let us find the ratio of the gravitational units, the units of capital G in SI and in the CGS system. That is, SI units of capital G, SI units of capital G over CGS units of capital G equal to Newton meter square per kilogram square means divided by kilogram square into gram square over dyne into centimeter square. Now this is equal to Newton is 10 raised to the power 5 dyne, meter square is 10 raised to the power 4 centimeter square into gram square divided by kilogram square means 10 raised to the power 6 gram square into dyne centimeter square. Dyne centimeter square. Dyne goes with dyne. Gram square goes with gram square. Centimeter square goes with centimeter square. And we are left with 10 is power 5 plus 4. 9 minus 6 equal to 3. That is 10 raised to the power 3. And therefore the value of G in the CGS system is 6.67 into 10 raised to the power minus 8 dyne centimeter square per gram square. So that is the value of small g, capital G in the CGS system. Now we come to gravity. Gravity is a special case of gravitation. That is, in gravity, one of the bodies must be Earth and the second body may be any other body lying on or near the surface of the Earth. It is due to gravity that all bodies fall freely towards the center of the Earth, and the acceleration with which a body falls freely towards the center of the Earth is called acceleration due to gravity. It is denoted by the symbol small g. Now let us derive an expression for small g. For that, suppose this is the Earth whose mass is capital M and a body of small m is placed on the surface of the Earth. This is the center of the Earth and capital R is the radius of the Earth. The mass of this body is small m. If F is the gravitational force or the gravity acting on the body due to the Earth, then according to Newton's law of gravitation, F equal to capital G into capital M into small m over R square. Actually, this R is the distance between the center of the Earth and the center of the body, and therefore it should be taken as radius of the Earth plus radius of the body. But the radius of Earth is about 6400 kilometer and the radius of the body is negligible as compared to 6400 kilometer. Therefore, the radius of the body may be neglected and we can take this distance as equal to radius of the Earth, that is capital R. If small g is the acceleration due to gravity, then according to Newton's second law of motion, F equal to ma and here a equal to g, that is F equal to mg. If I call this as equation number 1 and this as equation number 2, then comparing equations 1 and 2, we get mg equal to capital G into capital M small m over R square. This small m goes with small m and I am left with g equal to gm over R square, which is the required expression for the acceleration due to gravity on the surface of the Earth. Now, it is clear from this expression that acceleration due to gravity does not depend upon the mass of the body. That is, it is independent of the mass of the body, and therefore all bodies fall towards the center of the Earth with the same acceleration. And the value of acceleration due to gravity on the surface of the Earth is taken as 9.8 meter per second square, or it may be taken as approximately 10 meter per second square. And that is all in today's lecture. Enjoy this lecture and like it, share it, and subscribe it. Thank you very much.